What we're going to look at this morning is...
This video features two groups of students being introduced to mathematical argument and reasoning. They are looking at a series of statements and determining whether these are always true or sometimes true. The teacher begins the lesson by looking at some examples.
So just on the board, I've got two statements. X is an even number for statement A and X is a multiple of 4 for statement B. What I just want you to think about, and you've got about 30 seconds in your head, check with the person next to you. We started with two statements that I wanted the students to think about. If you knew one was true, could you be sure that the other one was true, and the other way round? It was a question that was fairly, I wouldn't say straightforward, but they're familiar with the vocabulary in it. They've probably seen a similar question before. So just getting them to be absolutely clear in their heads what it means for one statement to imply another, or for the other way around. And then we shared their findings. If statement A is true, is statement B always true, sometimes true, or never true?
Sometimes true.
Sometimes? Right, guys, if it's sometimes true, I need you to give me an example when it is true and give me an example when it isn't true. Henry? 4. So if a number is true, A is an even number, definitely that's true, and it's a multiple of 4, so it definitely is sometimes true. What I was trying to help them develop was a greater understanding of that mathematical, logical thinking, of being absolutely certain that if statement A implies statement B, then we know what that means. So getting them to think about exactly all the different connotations of a particular statement, and if from that they can be absolutely dead certain that something else is true. Could someone just give me an example of a value of X where sine of X is bigger than 0 and tan of X is bigger than 0? 45 degrees, brilliant. But is it always true? You can give me an example where sine of X is bigger than 0, but tan of X is not bigger than 0.
100 degrees.
Brilliant. So anything basically that's bigger than 90, but...
less than 180.
Spot on, absolutely brilliant. I'm going to give you 10 of these. It's exactly the same thing. We've got a statement A and a statement B. I'll give you all an individual copy. In the group of 10 that they had, they were a really good mixture. There were quite a few in there that the majority of them got fairly quickly. They kind of saw the nuances. They recognised with the modulus sign that there could be a negative solution. But there were some other ones that really got them to think about zeros, think about different ways of arguing.
That can't imply that, because you can get, as you said, minus 10, and that isn't smaller than 9, sorry. But if this is true, that will always be true.
A lot of these statements at first glance look like they might be vaguely true, so you've got to think about when might the implication not go the other way. You know, there were good examples of ones where they thought there was an implication going one way, and then I would kind of question, can you be absolutely certain, is there any way that a number that you put in might not quite cause what you think it's going to cause? And what was very nice is that they responded to that, and they thought really carefully about, why is he asking that question? Is that a question to just ask us to explain our thinking more clearly, or is it because there's genuinely a mistake here?
If you put x equals 0, x equals minus 1, y equals minus 1, and then you could put x, y equals 1, x equals minus 1, y equals 1.
Sometimes they were very much supportive of each other, and they kind of managed to convince themselves and each other that it was right, and they felt very confident to talk about the situations. Sometimes there was clearly a little bit of uncertainty, what they didn't agree. What was interesting is I didn't know if it would be quite self-contained. They didn't tend to talk to each other as groups. I don't think many of them were checking with each other, although occasionally they'd turn around and just talk with the group behind them. X squared is 25, X is 5. Which way are we going to go with that one? Clem, you're going to go, so B implies A?
Yeah.
Or A is implied by B. Right, guys, if we don't think it's both ways, what's our counter?
Minus 5?
Oh, yeah, X could be minus 5. I was very, very pleased with A, how they worked together. I would hope that they recognise that, particularly on some of the ones they didn't get right first time, that 2 heads is often better than 1 in terms of trying to spot flaws in their argument and getting the students to realise that talking about it and checking ideas with each other is not just a way of eradicating mistakes, but genuinely a way of making them better in the future so they won't make the same mistakes again.
So if y is negative,
Yep.
then x would also be negative, and
Right.
then in which case the product of the two would be positive.
Fantastic. So this can be true, but this could be positive,
Yeah.
so therefore it doesn't go that way.
Yeah.
How about going back the other way? If x, y was negative,
Yeah.
would y have to be negative?
No, because x could be negative and y could be positive.
Y could be x could be minus 1. They certainly seemed to enjoy it. They liked the challenge, and they liked the fact that some of them were very doable, but some of them made them think a little bit more. But no, I'm pretty pleased with what they took from that.